Andy, why the need to set a new land speed record?
It's a great question. We of course still hold the world land speed record at 1,228 kilometres an hour, set in 1997. Why another one, especially with the tight financial climate, concern about the environment? There is some competition. It's a fantastic time for the record. There are a couple of American teams, there's an Australian team, there's a New Zealand team. So it's going to be a fascinating competition. But that still doesn't answer the question, why are we setting a record? 5 years ago, when we started looking at the competition, whether we would be building a car, how fast it might go, one of the very first things that became obvious is that the UK, Europe, is short of engineers. Here now in South Africa, I read something yesterday, which was a great quote from the African Academy from last year, saying that there is a critical and ongoing shortage of engineers and technicians in South Africa. And the South African Department of Labour has sized that something like about 10,000 a year that you are short right now. So this is not just a UK or European problem, it's a South African problem, it's a world problem. How do we get young people inspired by science and engineering? And that, 5 years ago, was what triggered us to set a new land speed record, to push the boundaries of technology, to go as fast as we possibly could. The first four-figure record, 1,000 miles an hour, 1,600 kilometres an hour, is the target we're pushing. That's where technology will allow us to get. But we're going to have to develop some new science, we're going to have some huge challenges, and because we've got a unique car, we can share all of it. We can run it through a website, we've got 200 plus countries around the world following us. We've got just already 2 years from running the car, we have over 4,000 schools following it, a global audience of about 2 million students so far, who are excited and fired up by a fast car and the technology and the science and the materials technology and the geography of, you know, where are we going to find a desert, all this amazing science, and we're going to share that every single day with them while we do it. That is why we're doing it. We want to inspire that next generation of students who are going to be the scientists, engineers, technologists of the future.
Can you tell us a little bit about the car? Well, what is making it special? What is it enabling it to go that fast?
Well, the car challenge, there are a couple of huge challenges. First of all, you need a lot of power to do 1,600 kilometres an hour. So we have a state-of-the-art jet engine from a Eurofighter Typhoon. We're borrowing that from the UK. We're building our own rocket, 9 tons of thrust from the jet. The rocket, we have an additional 12 tons of thrust. So the car total, in horsepower equivalent, is 133,000 horsepower. That's 180 Formula One cars. This is a very powerful car. From a standing start, it will be 16 kilometres away in 100 seconds. But the sort of challenge, to feed the oxidizer into the rocket, we need to pump a ton of liquid oxidizer into the rocket in 20 seconds. So just to run the pump, we are using a Cosworth Formula One engine just to run the rocket pump. So the scale of the engineering challenge is huge. So that's to make the car go. It's all very well having a very powerful car, but the real secret is to control that power. So the big problem has been the aerodynamics and actually controlling the huge forces, something like 13 tons per square metre of bodywork at 1,600 kilometres an hour. Slightly too much nose up, the car will fly, slightly too much nose down, we'll crush it. And of course, as we accelerate and the shock waves form, that balance changes. So finding that perfect aerodynamic shape has taken us 5 years of an enormous amount of computing time using the world centre of this, the people who built helped us design the last car in Swansea University in the UK. All of that information is now on the web being studied by the student population, and it's that information which will allow us confidently to say, we've got a car that I can drive to 1,600 kilometres an hour that will stay on the ground and will go that fast.
You're confident you can achieve this?
Because of what modern technology offers us, and the fact that we built the previous car, we are using the same people, the same design principles, but computers have moved on 15 years. That's a long, long way in the last 15 years. So yes, we are very confident. We will still, of course, use the same step-by-step approach to, I'm not going to guarantee the car when it comes out of the shed next year will be exactly right and set up for 1,600 kilometres an hour. So we will prove it initially at 200 kilometres an hour on a runway in the UK. We will then bring it out to a desert in South Africa and do 300, 400, 500, 600, all the way up to 1,000, 1,050, 1,100, 1,150, step by step, checking everything. And while we're checking it, we're running live video and live data from the car onto the internet so that we're not doing all the checks. We've got the world's biggest team. We've got every student in the world has the opportunity to watch the car run and then analyse the data all at the same time. It's going to be a very, very exciting project.
Your final record attempt then is in 2013 at Hakskeen Pan in the Northern Cape here in South Africa. Why did you choose South Africa?
We wanted to come to we wanted to find the world's best surface. This is going to be the ultimate car. We needed a very, very good surface. Now, the traditional place to go is the United States, either to Salt Lake, which the Salt Lakes are a little bit short and they're very, very hard. Too hard actually for solid metal wheels that we'll be using. So we wanted to find the world's best dry lake bed, the world's best dry pan. And again, the States has a very large one, but it's in very poor condition and has been for years. So will that get better next year, 10 years, never? We don't know. We had to find other places. So we searched South America, North America, Asia, we looked all over Africa, we went to Australia. The best surface I could find, I went to visit all of them, the best surface I could find anywhere in the world was in the Northern Cape of South Africa. There are two choices. Hakskeen Pan, which is where Malcolm Campbell ran in 1929, which is a long way out of the way, and it was going to take a huge amount of effort to clear it. And Hakskeen Pan, which is much easier to get to and less effort to clear. So the choice was very obvious. We've got a fantastic partnership with the Northern Cape, who are in the process of building the world's best racetrack, and in 2 years' time we will be approaching 1,000 miles an hour, 1,600 kilometres an hour in Hakskeen Pan in Northern Cape. Can't wait.